welcome everyone to this new episode of the Student Spotlight. In this series, we're interviewing past students from CCIR about their experience, their work. My name is Oliver, and today it's a great pleasure to have with us Rohan Kalluraya, a 17-year-old student who worked with the CCIR Future Scholar Program under the course of Mathematical Optimization taught by Dr. Benoit Legat at MIT. Rohan is a current student at DLRC school in Pune, India. And today he's been so kind to join us to talk a little bit about his experience here at CCIR, a really cool project that he's been working on that is actually currently being taken up by a research firm in India called AG Diagnostics. We'll talk a little bit about what exactly he looked into during his research program at CCIR. We'll also talk a little bit about his experience working with Dr. Legat from MIT. And we'll also talk a little bit, hopefully today, about the current applications of this work within industry, all of which is super exciting. So Rohan, thank you so much for joining us today.
Yeah, pleasure to be here.
So I think to get started, Rohan, would you be so kind as to give sort of a brief introduction of yourself? Just say a little bit about who you are, where you come from, what your academic interests are, and then we'll go from there.
Right. So, hi everyone. As just mentioned before.
Yeah.
Oh, sorry, Oliver. Just mentioned before, and I am Rohan from Pune, and I'm in grade 12 right now. I really enjoy mathematics and I'm trying to look at various applications of math. I'm exploring applications of math in different life sciences. So in this course, I really enjoyed how math was applied in computer science, where I studied optimization and control.
Okay.
Yeah.
So tell me a little bit about this course that you were in. So it was a course in applied mathematics. So first tell me the title of your course, and if you're able to give sort of a general outline of the basic concepts and themes of the course, how would you sort of describe it?
Yeah, sure. So the course was mixed integer linear programming, and it was a course on optimizing. So let me explain what that is. So optimizing is basically when you want to find the minimum possible cost of any activity, then you need to find the optimum solution for that activity, or you need to maximize your profits. That's like an optimization problem. So such problems there are different ways to solve such problems, and mixed integer linear programming is one of them. So in this course, I studied about this class of solutions to solving the optimizing problems.
Mm-hmm. So can you give us a concrete example of a optimization problem?
Sure. So I'll give a very basic example. There is, suppose, a equation a plus b equals to 5, and you are asked to find the maximum value of a into b. So that is, you have a constraint and you need to find the optimum value you can get using that constraint for a given expression.
Okay, interesting. So tell me a little bit more then about mixed integer linear programming. So I have no idea what that is, to be very frank. So tell me a little bit about how this functions as a solution to optimization problem.
Right. So mixed integer linear programming is a very robust solution, like a very robust method to solve these optimization problems. And it's very simple, really. You give linear constraints like this, like the example before, a plus b is equal to 5 is one linear constraint. So you give many such linear constraints depending on whatever problem you have. And then it's very easy for the computer, and using many methods, it's very easy to optimize given linear constraints. So the key in mixed integer linear programming is converting any problem into one with linear constraints, and then optimizing such linear constraints can be done very easily.
Mhm.
Yeah.
So let's talk a little bit about the specific problem that you worked on
Mm.
and sort of your process of sort of coming to grips with the problem through mixed integer linear programming. So I took a look at your paper.
Yeah.
Your paper is focused on this problem called the multiple traveling salesman problem.
Right.
Can you tell us a little bit about what this problem is, and in what sense is it an optimization problem?
Sure. So the multiple traveling salesman problem is one where there are many salesmen and they are at a main center, and each salesman has to take one route that travels across some group of centers, and each salesman takes a different route. And the problem is that we need to minimize the total transport costs, and we need to make routes for each of the salesmen which start at the main center and then come back to the main center, so that each center is visited exactly once.
Mhm, mhm. Yeah,
So
so we might imagine, let's say, not salesmen, but let's say pizza delivery people having
yeah,
sort of a
sure,
similar issue where you have
sure.
5 pizza delivery people who need to hit
Mhm.
15 different houses, and we want to figure out what is the most efficient route through all of those 15 points for all of these 15 sales or like the pizza guys. And what we're
Right,
trying to do is optimize the route so that
right.
we minimize transportation costs and have the maximally efficient way of sending out all the pizza.
Exactly. Yeah.
Okay, great. So tell me a little bit more about how you use mixed integer linear programming to solve this problem.
Mhm. So now we have this problem, and what we first have to do is convert this into linear constraints. So suppose you consider each center to be a node on a graph, then one constraint has to be there has to be one edge entering a node and one edge leaving the node. So that's one linear constraint. Then another linear constraint can be all salesmen start from the main center. So the sum of edges leaving the main center has to be the number of salesmen there are. That's another linear constraint. And like this, I had to think of 8 to 9 linear constraints that modeled my entire problem. And once you model your entire problem using linear constraints, there are very efficient solvers using different programming languages like Julia programming language. And those can solve these linear constraints and find an optimal solution to any problem.
Hmm. So tell me a little bit about Julia, because Julia, as I understand it, is actually a programming language that your professor Benoit, Dr. Benoit Lagat, developed himself. So tell me
Oh,
about
okay.
sort of
Yeah.
yeah. So in case you didn't know that, actually, Benoit
Yeah.
actually was one of the main authors of this programming language.
I
So
didn't know.
tell me a little bit about your experience of working with Julia, and then by extension, also your experience of working with someone like Benoit, who isn't just an expert actually in this programming language, but one of the original creators of it.
Right, right. So definitely working with Mr. Legat was a really exciting experience. He knew so much about the field, and I learned many new foundational concepts in optimizing. And Julia programming language is relatively new, and it's actually combines the advantages of Python and C++. So the the efficiency of Python, the efficiency of C++ with the ease of coding of Python. So that's how Julia programming language is. And as Mr. Legat had mentioned in the course, it's relatively new, just started in 2011-12, and it's expected to rise a lot in the future as it's very math focused, and many math based problems can be easily solved using this language.
Hmm. Hmm.
Yeah.
Yeah, so I think this is maybe a useful moment to pivot a little bit to talk about your experience in the course itself.
Mhm.
Um, So with your course, you got to work with Dr. Lagat, who is a current researcher in applied mathematics at MIT. Um, you also worked with a TA who I believe is also from MIT. Is that correct?
I think he's from a Belgium institute. He
Okay,
was
right,
living
gotcha.
in Belgium. Yeah.
Okay, understood. Um, so yeah, tell me a little bit about your interactions with your professor and your TA, and also with your peers. Because as far as I understand, have you ever worked in applied mathematics before?
No, actually, I haven't.
Yeah.
And
So tell me about this experience of sort of diving into this new field with sort of other peers who are, let's say, maybe a little bit more nerdy than your average, who share a little bit more in common with you in terms of your interests. What was this
right,
experience like of sort of exploring an academic field in this level of depth?
right. So this was definitely a first for me. And working with MIT professors and such high level TAs, they were so friendly. I could ask them any question I wanted and always open to discussion. So I really understood deeply like what mixed integer linear programming was, and like basics of how these solvers run, like what's behind these solvers on Julia programming language. So when you input these linear conditions, what goes on in these solvers that makes them come up with a solution so quickly. So
Mhm,
that's what my main learning was through this course. And I think that even though it was online, it was very easy to interact with everyone in the class, even my peers. I could easily connect with them. Like they're all my friends now. Like we regularly message on Instagram, and it's great. It's been a great experience.
mhm.
So
Yeah, and I think we'll pivot now to talk about the last thing, which is actually quite exciting. I learned just a few days ago that your work at CCIR of sort of looking at the traveling salesman problem has actually been applied in some work with AG Diagnostics. So
right,
first off, tell me a little bit about AG Diagnostics, the kind of work that
yeah,
they do, and then tell me about how your research is useful or is being currently applied at this firm.
right. So AG Diagnostics is one of Pune's leading, my home city Pune's leading pathology centers, and they conduct all these COVID tests and many various different tests for many diseases. And they have almost 40 centers spread across my home state, Maharashtra. So the problem they had was they needed to collect biomedical waste from each center every 2 days. And they have two salesmen, like you can there are two waste collectors, we can call them two salesmen, and they have to make routes that traverse through each of those 40 centers over 2 days. So my problem, I wanted to help some company in real time using my project. So I was approached by them, and I could actually implement my solution for this problem by first inputting data about these 40 centers into my program, then finding the costs of driving per kilometer in Pune city and the time taken to drive on Pune roads. So using all this information, I inputted all this data into my program, and I could find four routes that cut down costs from almost rupees 1400 per day to rupees 893 per day for the company, a
Mhm,
35% reduction in costs. And yeah, so it was a great experience.
mhm,
I really enjoyed that. I really like that I could actually use my project to make real world impact.
mhm, mhm. Yeah, and that's incredibly cool to hear, especially at such like a early level, as a high school student, to be able to sort of use programming um, and sort of achieve this kind of real world impact in industry is really, really quite exciting. And I would dare venture to say even quite uncommon for the students that we work with. We've had like one other student I remember who also did an AI project that eventually got picked up by some firms as well. But it really is a testament to sort of the strength of the work that you're doing, that it can have sort of these practical applications. Um,
Right.
so as we sort of approach the very end of um, this interview, I want to also ask you a little bit, Rohan, about just anything that you want to share with sort of students currently interested in exploring research, or even more specifically interested in doing research in areas that you're working on, such as mathematics and computer science. What advice, now that you've gone through this process, would you give to someone who's sort of just looking into this?
So I think definitely working with Mr. Leggett was a really nice experience. With someone with so much knowledge, I could really ask any question I wanted and really understand the depths of what I was studying. So I would really encourage anyone interested to find a really nice professor to work with, and they can really guide you. And even if you may not get a project or anything at the end, really learning about it is the key here. And you can always use whatever knowledge you gain to further explore the field on your own in the future. So yeah, definitely my advice would be find a really nice professor to work with. And I think CCI definitely provides that opportunity to any student out there. So
Excellent.
yeah.
I think that's excellent advice. Um, when students also ask me, um, so I'm also currently sort of a PhD student at Georgetown, and whenever my students ask me how they should pick their courses, my advice
Mhm.
is always think about which professors you want to work with.
Ah,
That's, if
right.
anything, almost more important than the topic that you're looking into.
Mhm.
So I think that's excellent advice, Rohan.
Yeah.
Well, that just about, I think, concludes this episode of the Future Scholar Student Spotlight. Is there anything else you want to share with, anything you want to say to your professor, your TA, or your peers? Anything to anyone that is listening to sort of conclude this interview, Rohan?
Yeah, sure. I think that, like, if anyone is currently pursuing research in any field they are, I really encourage them to start at an early age.
Mhm.
Like, it really helped me get very valuable exposure. And now even I know, like, I have some idea about what I want to pursue further in college and in my career. So this course really helped me gain, like, further deepen my interest for applied maths and see how it could be actually used in real life and applied in the real world. Yeah, so basically just start at an early age. The exposure is really important.
Yeah, I think
Yeah.
that's excellent, excellent advice. And it really is quite heartening to hear, Rohan, that this has been helpful for you for figuring out sort of your interests and what you want to do. At the end of the day, I think at CCIR, that's um, really the dream scenario for us, that we're able to help students in this kind of way. So I'm incredibly, incredibly happy to hear that. Well,
Yeah.
that just about that's a really good point, I think, to end this interview. So thank you once again, Rohan, for your
Yeah.
time today. It's been incredibly interesting and impressive to hear about your journey at CCIR and the work that you've done here and how it's been being applied in industry and in the real world. Um, Once again, thank you so much for your time today, and
Yeah.
congratulations once more on being nominated as a Spotlight Scholar.
Wow, no problem. Glad to be here.